Consider a gas-filled container that has a movable piston. It is exposed to an atmospheric pressure of 1 atmosphere. Click on one of the buttons to see animations of how temperature, pressure, or the number of gas particles affects the volume that the gas occupies. You can increase the pressure by adding a weight on top of the piston. Let's add a weight that will increase the pressure on the top of the piston to 2 atmospheres. As the pressure on the gas increases, the volume that the gas occupies decreases. The volume that the gas occupies will continue to decrease until the pressure of the gas equals the external pressure on the piston, which is 2 atmospheres. The volume occupied by the gas will be half its original volume. You should see that the volume is inversely proportional to the pressure. V is proportional to 1 over P. Adding a proportionality constant, K, we can write volume equals K divided by pressure, or pressure times volume equals K. This relation is known as Boyles Law, which states that the volume of a fixed amount of gas is inversely proportional to the gas pressure at constant temperature. As the pressure on the gas decreases, the volume that the gas occupies increases. The volume that the gas occupies will continue to increase until the pressure of the gas is equal to the atmospheric pressure on the piston, which is 1 atmosphere. Let's use a Bunsen burner to increase the temperature of the gas. As the temperature is raised, the average velocity of the gas particles increases. Thereby, the frequency and intensity of collisions of gas particles with the container walls increase. Pressure, which is defined as the force exerted per unit of surface area, will clearly increase as the frequency and intensity of collisions increase. Pressure for a fixed amount of gas at constant volume is directly proportional to the temperature. Note that as temperature is doubled at constant volume, the pressure exerted by the gas, when the Bunsen burner is removed, the temperature of the gas decreases. The average velocity of the gas particles decreases, thereby the frequency and intensity of collisions of gas particles with a container walls decrease. Pressure for a fixed amount of gas at constant volume is directly proportional to the temperature. Let's use a Bunsen burner to increase the temperature of the gas. As the temperature of the gas increases, the volume that the gas occupies increases. In other words, volume is directly proportional to the temperature of the gas. We can write volume equals K times temperature, where K is a proportionality constant. This relation is known as Boyles Law, which states that the volume of a fixed amount of gas is directly proportional to the gas temperature at constant pressure. Note that as the temperature is doubled at constant pressure, the volume that the gas occupies. When the Bunsen burner is removed, the temperature of the gas decreases, and the volume that the gas occupies decreases. The volume that the gas occupies will continue to decrease until the temperature of the gas equals the external temperature. Gas particles are entering the container. As the number of particles, or equivalently the moles of gas, increases, the volume that the gas occupies increases. In other words, volume is directly proportional to the number of moles of gas. We can write volume equals K times N, where N is the number of moles of gas and K is a proportionality constant. This relation is known as Avogadro's law, which states that at constant pressure and temperature, the volume of the gas is directly proportional to the number of moles of the gas. In this animation, the moles of gas particles is doubled, and correspondingly the volume occupied by the gas is doubled.